In the vast and starry expanse of the constellation Orion, there exists a celestial body that has long captured the imagination of astronomers and stargazers alike. This star, known as Betelgeuse, stands out not just because of its position in the sky, but due to its extraordinary characteristics and the mysteries it harbors. For centuries, Betelgeuse has fascinated those who observe the heavens, not only because of its sheer size and brightness, but also because of its enigmatic and unpredictable nature. Betelgeuse is classified as a red giant, a type of star that has expanded to many times the size of our Sun and glows with a reddish hue due to the cooler temperatures on its surface. This colossal star is much larger and more massive than our Sun, occupying a volume so immense that if it were placed at the center of our solar system, it would extend beyond the orbit of Mars. However, it is not just Betelgeuse's size that intrigues scientists. In recent years, the star has exhibited a series of unusual behaviors that have sparked intense interest and speculation. Most notably, Betelgeuse has been observed dimming significantly, a phenomenon that was not fully understood and led to widespread discussion about the star's future. Additionally, the star has experienced violent vibrations or stellar quakes, which have only deepened the mystery surrounding it. These strange occurrences have led some to speculate that Betelgeuse may be nearing the end of its life and could soon explode in a spectacular supernova. Yet, as exciting as that prospect may be, there is another more chilling possibility. What if instead of exploding, Betelgeuse is on the brink of collapsing inward, potentially leading to a different kind of cosmic event? To explore these questions, we must delve into Orion's shoulder where Betelgeuse resides and examine the star's recent changes in detail, considering what these might mean for Earth and the wider universe. Betelgeuse is not just any star. It is one of the largest and most massive stars known, a true giant in every sense of the word. With a size that is approximately 1,000 times larger than our own Sun, Betelgeuse's sheer scale is difficult to comprehend. This star's diameter is so vast that if placed in the center of our solar system, its outer layers would extend well beyond the orbit of Jupiter, engulfing the inner planets including Earth, Mars, Mercury, and Venus. Such a star, with its immense gravitational pull and radiant energy, commands attention not only for its beauty, but also for the potential dangers it poses. Despite its impressive appearance and the awe it inspires, Betelgeuse is also a reminder of the fate that awaits all massive stars. Unlike smaller stars, which can burn steadily for billions of years, massive stars like Betelgeuse have much shorter lifespans. They consume their nuclear fuel at a much faster rate, leading to an inevitable and catastrophic end. At some point, Betelgeuse will exhaust its fuel, leading to a collapse that will likely result in a supernova, one of the most powerful and violent events in the universe. The exact timing of this event is uncertain, making Betelgeuse a cosmic time bomb, a ticking clock that could go off at any moment or thousands of years from now. This uncertainty is what makes Betelgeuse such a compelling object of study. Located just 650 light-years from Earth, it is close enough to be observed in great detail, yet far enough that a supernova would not pose a direct threat to our planet. Over the centuries, Betelgeuse has captivated astronomers with its brightness, its distinctive reddish hue, and the dramatic fluctuations in its light output. We watch it with a mix of awe and curiosity, trying to unravel the mysteries hidden within its fiery depths. Interestingly, despite its brilliance, only about 13% of Betelgeuse's radiant energy is visible to us. The rest is emitted in wavelengths of light that are invisible to the human eye, including infrared radiation. If we could see the full spectrum of its emissions, Betelgeuse would outshine even Sirius, the brightest star in our night sky, dominating the heavens with its incredible luminosity. To fully appreciate the scale of Betelgeuse, imagine a star so large that its radius is 1,000 times that of our Sun. Such a star would stretch across the solar system, extending beyond the asteroid belt and coming perilously close to Jupiter. In this scenario, the inner planets, including Earth, would be swallowed by the star's outer layers, lost within its vast, glowing atmosphere. The thought of a star of this size is both inspiring and terrifying, as it illustrates the incredible power and scale of celestial bodies in our universe. However, the wonders of Betelgeuse do not end with its size. This star is also known for its dramatic and often unpredictable behavior. Every 1,000 years or so, Betelgeuse sheds a significant portion of its mass in a process that releases an enormous amount of material into space. This ejected material forms a spectacular nebula, a cloud of gas and dust that is 250 times larger than the star itself. This nebula surrounds Betelgeuse with a ghostly, ethereal haze that can be seen from Earth, adding to the star's mystique. The nebula, which extends out to a distance of 30 astronomical units, the average distance from the Earth to the Sun, is a testament to the dynamic processes occurring within and around Betelgeuse. It invites us to witness a cosmic dance of wonders, a dance that reveals the inner workings of this mighty star and the secrets it holds. By studying this nebula and the processes that create it, astronomers hope to gain a better understanding of the life cycle of massive stars, including the eventual fate of Betelgeuse itself. At the core of Betelgeuse lies the engine that drives its incredible luminosity and the dramatic events that have been observed. This engine is the process of nuclear fusion, where hydrogen atoms are fused together to form helium, releasing vast amounts of energy in the process. This energy is what makes Betelgeuse shine so brightly, and also what has allowed it to grow to such an enormous size. However, like all stars, Betelgeuse has a finite supply of hydrogen, and as this fuel is depleted, the star undergoes significant changes. Once the hydrogen in Betelgeuse's core is exhausted, the star begins to fuse helium into heavier elements such as carbon. This process releases even more energy, causing the star to expand and glow even more brightly. Yet even this grand stage of fusion has its limits. Eventually, Betelgeuse will begin to fuse elements into iron, a process that does not release energy but instead absorbs it. When this happens, the star's core will no longer be able to support the weight of the outer layers, leading to a catastrophic collapse. The gravitational pull of the star's outer layers will overwhelm the core, causing it to implode. This collapse will trigger a supernova, a colossal explosion that will release more energy in a few moments than the sun will emit over its entire lifetime. This explosion will be so powerful that it will create shock waves that ripple through the surrounding space, potentially triggering the formation of new stars and planets in nearby regions. Betelgeuse's supernova will be a sight to behold, a cosmic event that will be visible from Earth even during the day, shining with a brightness comparable to that of a crescent moon. Stars are born, live, and die in a process that spans millions or even billions of years. Over the course of their lives, they undergo dramatic changes in size, color, and brightness. Betelgeuse, like many massive stars, started its life as a vibrant blue star, burning hot and fast as it consumed its hydrogen fuel. As it aged, it cooled and expanded, taking on the red hue that we see today. This transformation from blue to red is a common fate for massive stars, signaling that they are entering the final stages of their lives. The color of a star can tell us a lot about its age and its future. In the case of Betelgeuse, its deep red color has been noted by observers for thousands of years. In the 2nd century BC, Chinese stargazers recorded Betelgeuse's distinctive red color in their celestial charts, noting its prominence in the constellation Orion. This observation was later passed down to other civilizations, including the ancient Greeks and Romans. The famous Roman astronomer, Timo, writing in the 2nd century AD, described Betelgeuse as having an orange or reddish appearance, a characteristic that has remained consistent over the centuries. This consistency in Betelgeuse's coloration, observed by different cultures and civilizations across time, adds to the intrigue surrounding this star. It suggests that Betelgeuse has been in its red giant phase for a considerable period, slowly evolving as it nears the end of its life. The story of Betelgeuse took a surprising turn in 2019 when the star suddenly and unexpectedly dimmed in brightness. This dramatic event puzzled scientists and led to a flurry of research and speculation. For a star that had been so reliably bright for so long, this dimming was highly unusual and raised questions about what was happening inside Betelgeuse. Some researchers proposed that a large cloud of dust, possibly shed from the star's surface, had moved in front of Betelgeuse, blocking some of its light from reaching Earth. However, this explanation did not fully account for the extent of the dimming, and the true cause remained elusive. Others speculated that a massive object, such as a planet or a brown dwarf, might have disturbed Betelgeuse's surface or even been absorbed by the star, leading to the observed changes. In the months following the dimming, Betelgeuse began to brighten again, eventually returning to near its previous brightness levels. This unexpected recovery only added to the mystery, as stars generally do not recover so quickly from such significant changes. Scientists continue to study Betelgeuse in an effort to understand the underlying processes driving these fluctuations. One theory is that Betelgeuse, like some other stars, may be going through a natural cycle of brightening and dimming. For example, the star Mira is known for its regular cycles of expansion and contraction, which cause it to vary in brightness over time. This phenomenon, known as a variable star, is common in the universe and can be seen in other stars such as Algol and several dozen others that are visible in the night sky without the aid of a telescope. The events of 2019 also brought attention to another aspect of Betelgeuse's behavior: its tendency to undergo massive ejections of material. These ejections, where the star throws off vast amounts of its outer layers, can create dust clouds that obscure the star's light. In 2019, such an ejection may have created a dust cloud that covered a significant portion of Betelgeuse's surface, leading to the dramatic dimming observed from Earth. This event highlighted the dynamic and volatile nature of red giant stars like Betelgeuse, which can experience sudden and violent changes as they near the end of their lives. The brightness of Betelgeuse declined to levels that were unprecedented in modern times, dropping from being one of the 10 brightest stars in the night sky to being among the 20 brightest. This marked change in brightness was a clear indication that something significant was happening within the star. In the months that followed, Betelgeuse's brightness began to recover, but the reasons behind this fluctuation remained the subject of ongoing research. Scientists have proposed a range of theories to explain these changes, from the possibility of massive sunspots on the star's surface to the idea that multiple cycles of brightening and dimming might have coincided, creating the observed effect. One particularly intriguing possibility is that the dimming and brightening are signs that Betelgeuse is approaching the final stages of its life and may soon undergo a supernova explosion. Some researchers even suggest that the supernova may have already occurred, with the light from the explosion still traveling through space to reach us. This idea is based on the fact that supernovae are real and relatively common events in the universe. In 1987, for example, a supernova was observed in a satellite galaxy of the Milky Way, providing a glimpse of what might one day happen with Betelgeuse. Researchers studying Betelgeuse have developed models that suggest the star is in a late stage of carbon burning, a phase that typically precedes a supernova explosion. If this is true, then Betelgeuse could be on the verge of a magnificent and catastrophic event, making it one of the most likely candidates for the next supernova within our Milky Way galaxy. The idea that we could be witnessing the final moments of such a massive star is both thrilling and sobering. However, understanding Betelgeuse is not an easy task, as conflicting observations and data make it difficult to draw definitive conclusions. While Betelgeuse has experienced massive ejections of material and subsequent recoveries, these events do not necessarily indicate that a supernova is imminent. The star's behavior could be part of a natural cycle, or it could be something more. One of the challenges in studying Betelgeuse is the difficulty of observing it in detail. Despite being relatively close to Earth, the star is surrounded by a thick veil of gas and dust that makes it hard to see what is happening on its surface. Scientists have been observing Betelgeuse for centuries, noting changes in its brightness and other characteristics that suggest it is aging and could go supernova in the near future. However, there is still insufficient evidence to say with certainty when this will occur. A supernova is an extremely bright explosion that occurs when a star reaches the end of its life. If Betelgeuse were to go supernova, it would be visible from Earth with the naked eye and would be one of the brightest objects in the night sky. The brightness of a supernova depends on the size of the exploding star, and since Betelgeuse is a very large star, its supernova would be extremely bright, comparable to the light of a crescent moon. This event would be visible even during the day and would remain a prominent feature in the sky for weeks or even months. In conclusion, the fate of Betelgeuse remains one of the most intriguing mysteries in modern astronomy. The star's recent behavior has sparked widespread interest and debate, with scientists and stargazers alike wondering whether we are witnessing the final stages of a massive star's life, or if Betelgeuse has already exploded in a supernova that has yet to reach our eyes. The possibility that Betelgeuse could go supernova in the near future is both exciting and humbling, reminding us of the immense power and unpredictability of the cosmos. As we continue to observe and study this fascinating star, we may one day witness one of the most spectacular events in the universe. A supernova explosion that will light up the night sky and leave an indelible mark on our understanding of the universe. Until then, we can only speculate and marvel at the wonders of the cosmos, knowing that the universe still holds many secrets waiting to be discovered.